You know all those bridges and buildings we rely on every single day? Well, it turns out they have a hidden price tag, and it goes way beyond just the cost of steel and concrete. We're about to uncover the true cost of building our world. Think about it. So much of our modern world is held together by steel. But from the moment it's put in place, it's fighting a constant battle. We're talking about corrosion, rust. It's this relentless, slow-motion disaster that never stops. And the fight to preserve it all costs a whole lot more than you might imagine. So, this brings us to the big question, doesn't it? We know we have to protect all this infrastructure, but what's the true cost of doing that? And believe me, I'm not just talking about the price of a can of paint. To really dig into this, we're going to zoom in on a very specific case study, just a single steel bridge fighting its own battle against time. But of course, this isn't just about one bridge. This is a universal problem. Every single bridge, every skyscraper, basically any structure made of steel, is in this constant fight to survive. The choices we make to protect them, they have consequences that ripple out for decades, even centuries. So how do you even begin to measure those ripples? Well, we need a totally new way of looking at value, one that lets us see the complete picture. The accounting firm KPMG actually came up with a fascinating way to do just that. The core idea is pretty simple, really. If you want to understand the real impact of any decision, you have to look beyond the normal profit and loss statement. You have to account for, well, everything. So they developed this method. They call it calculating a project's integrated profit and loss, or what they call its true value. The best way to think of it is like putting on a pair of X-ray glasses. All of a sudden, you can see all the hidden costs a project creates for the environment and for society as a whole. It all breaks down into three simple pillars. First, you've got the financial cost, or F. That's the easy one, the price you see on the invoice. Then you add E, the environmental cost. This is where you actually put a dollar value on things like CO2 emissions and pollution. And finally, you add S, for the social cost, so the impact on public health and the community. You add F plus E plus S, and that gives you the true value. Okay, now for the fun part. Let's take this true value formula and apply it to our bridge. It's time to see those hidden costs come into the light. All right, so for our bridge, we're planning for a 100-year lifespan. We've got two choices to protect it. Option one is good old traditional paint. It seems cheaper up front, but you have to keep stripping it and reapplying it over and over. Option two is something called hot dip galvanizing. This is a one-time process where you dip the steel in molten zinc, creating a super durable, long-lasting protective layer. Now, this is the crucial part. We're not just thinking about next year's budget, we're thinking about the next 100 years. Yeah, paint looks cheaper on day one, but which option is actually more expensive when you factor in everything? And here are the results from the KPMG analysis. Whoa, just look at the scale of these numbers. Over 100 years, the true value of the galvanizing option comes in at a negative 18.7 billion new Taiwan dollars. But then, look at the traditional paint. Its true cost is a staggering negative 23.3 billion. That is a difference of over 4.6 billion. Let's just focus on that number for a second. Over 23 billion. That is the real cost that society and the environment are paying for choosing the quote-unquote cheaper option. So where does a massive number like that even come from? Well, the difference is all that hidden stuff we talked about. The E and the S in our formula. It's the cost of all the extra CO2 emissions from constant maintenance, the pollution from making and applying paint again and again, and all the resources you burn through with all those repeated jobs. That's the true cost. So this one case study really shows us something powerful. Making smarter choices right at the start can have a massive positive impact down the road. And this is really the foundation for building a much greener future. You know, this whole idea ties directly into the concept of a circular economy. The goal there is to eliminate waste and keep using our resources, not just throwing them away. So using a material that can protect steel for 100 years with very little maintenance, that's a perfect example of the circular economy in action. So the key takeaway here is pretty simple. Smart design isn't just about how a structure looks, it's about thinking about its entire life cycle. Choosing durable, low-maintenance materials from day one is honestly one of the most effective ways we can reduce our long-term carbon footprint. And here's the good news. companies don't have to make this switch all by themselves. Governments are now starting to step in to help these industries make the transformation. Because they recognize how important this shift is, governments are offering real financial support. They want to give manufacturers an incentive to invest in the kinds of technology and processes that lead to this more sustainable, true value way of doing business.
And we're not talking about small change either. As you can see here, companies can get up to 30 million NTD for low-carbon upgrades and up to 20 million for smart factory upgrades. This funding is specifically designed to make that initial investment in better technology a lot more achievable.
So what can you actually use this money for? All kinds of cutting-edge stuff. Things like doing a deep carbon footprint analysis, implementing IoT sensors on the factory floor, using AI for quality control, or even developing brand new low-carbon products. It's all about helping manufacturers get smarter and greener. Which leaves us with a final thought to chew on. This true value way of thinking totally transformed our understanding of a simple bridge. So imagine for a second, what if we applied it everywhere? If we could see the hidden financial, environmental, and social costs of everything we make and everything we buy, what would we choose to build then?